I will check online. I was busy Saturday doing decathlon. Did I say that right? Decathlon, yeah. All right, guys. So today we're going to do notes 29, definite integrals part 2. Notice that we are not going to do the proof. Some of you might be bothered, like why this works. And we are going to do the proof. We are, yes. We're going to do the proof tomorrow. Today is Monday. Tomorrow will be a better day for the proof day. I think today is just a better day to see what the proof is and get it out of the way. So in essence, this is what we're going to be doing today, but we're going to do the proof of why this works tomorrow. And we kind of already talked about it. Oh yeah, our quiz is going to be moved from tomorrow to Wednesday. So our quiz is going to be moved, guys. We'll have an overview tomorrow after school. Okay, you guys ready? Everything we've done: LRAM, MRAM, RRAM, trapezoid, area under the curve. For the first part, not this part where we're doing antiderivative FTOC1, but everything we did last week, pretty much. Yeah, fundamental theorem of calculus part 1. All right, guys. So here we go. All I'm doing is following this rule, and we kind of already introduced it to you guys last week. So first, I go equals, and I look to see what my f prime or my function is. In this case, it is sine x. What is antiderivative of sine x? Cosine x. I either make a line or I put it in a bracket. It does not matter. And I'm going to say 0 to pi. And according to this, it says upper minus lower. So I write cosine pi minus cosine 0. Cosine of pi is -1 minus cosine of 0 is 1. So -2. Are we okay, guys? And that's it. I don't know why I put so much white space. I could have done something with it. Let's see. So remember this question. So example 2 from a few days ago, we said a particle starts at x equals 5. I don't know if I might have changed that number. No, I think I left it at 5, but I think we never answered it. I moved along the x-axis with velocity c squared, and we use 6 subintervals from 0 to 3, LRAM, MRAM, RRAM. And here's what we said. We said LRAM, it looks like it's approaching 9. MRAM, that looks really close to 9. And RRAM, that looks like it is approaching 9 as well. And we said if n approaches infinity, the number of rectangles under this curve was infinite, it would equal 9. Do you guys remember that? Okay, so let's see if using our little formula, what formula, Chavez? This guy. Let's see if using our little formula gives us that answer, guys. So I have my velocity, which is t squared. Okay, hold on. Let's answer this first. Distance traveled was 9, and there didn't have any units on that. So just 9. You could also say displacement because area under the curve is always the velocity is always increasing. So displacement and distance is the same on this one. All right. So let's see. Integral from 0 to 3 of t squared. Let's see if this gives us 9, guys. Let's see, because that's what we found. We found the area under the curve, right? Area under the t squared curve. All right, so let's go ahead and take antiderivative of this guy. So antiderivative is t to the 3rd power over 3. I have limits, so either make a straight line and put 0 on the bottom, 3 on the top, or you can put it in brackets. It means the same thing. Here we go. 3 to the 3rd power over 3 minus 0 to the 3rd power over 3 equals One of these 3's cancel out. That's 3 squared. OMG, we get a perfect 9. It works, guys. Oh, that's one of the better happy faces I've ever drawn. It works, guys. So all you're doing today is practicing taking antiderivatives. That's all you're doing. And using the fundamental theorem of calculus part 1, which is what we're doing right now. Okay, this one has 2 terms. So we're going to put it in brackets. What's the antiderivative of x cubed? Perfect. Plus, what's the antiderivative of 1? X. Because there's 2 terms, here are my 2 terms. Negative 1 on the bottom, 3 at the top. I'm going to do upper minus lower. So here we go, upper minus lower. 3 to the 4th over 4 plus 3, giant parenthesis, minus negative 1 to the 4th over 4 plus negative 1. Let's see if we need the assistance of a calculator. I hope not. 3 times 3 is 9. 9 times 9 is 81. 81 over 4, is that a number? Nope, it doesn't reduce. So I'm going to have this 81 over 4 plus 3. Let's see what I have here on the side. Negative 1 to the 4th is 1. So I'm going to have 1/4 minus 1. So I'm gonna drop the parentheses and distribute 81 over 4 plus 3 minus 1/4 plus 1. So let's see. 81 minus 1 is 80, and 80 divided by 4 is 20. You guys see what I did? I added these 2 in blue. So 20. And then 3 plus 1 is 4. So I guess I could have just written it all together. So I got 24. You didn't have to go that route, guys. You could have just figured out the number here, figured out that number. That's negative 3/4, and then minus a negative. And it doesn't matter, however you do it. I tried not to use a calculator, but I have a calculator on my left hand here, so shame on me. Okay, anyways. Ooh, look at this one. I don't know, Chavez. What's the antiderivative of 1 over x?
ln.
Yeah, heck yeah. ln DeGeneres. ln of x. Really, I should be putting absolute value, but my limits there are positive, so I'm not going to worry about it. Put a 1, put a 5. That little stick, Mazuka probably recognizes it from computer programming. That means he evaluated that. Oh, yeah, we will do the little line again, and then the corner to the corner. Same thing, yeah. That little line means evaluated that. If you've done enough programming, you'll see that line come into programming, guys. All right, upper minus lower. You can put an equal sign immediately after that. This is correct math. And you can just go ln. I'm not going to be able to get ln DeGeneres out of my head now. ln of 5 minus ln of 1. Hopefully everyone knows that ln of 1 is 0. So this is just ln of 5. Yes, that's your question. Yes. 5 divided by 1 is 5. So happy face with a little ears here. Okay. Oh, okay. All right. All right, check this out, guys. James and the Giant, what? I'm not sure if I've seen that one. Could you do this one with geometry if you didn't know how to do the antiderivative of 3? Of course you know how to do the antiderivative, right? But this is just a function 3. So you could do all of these if you know the shape with geometry. Look, here's y equals 3. And I'm going to say here's 3. And I'm going to say here's 7. Let's find the area. This is just a rectangle. That's just a rectangle, guys. Let's see, what's that rectangle? 7 minus 3 times 3. 7 minus 3, that's 4. 4 times 3. So that's 12. Let's see if we would have gotten that. Antiderivative of 3 is 3x. And I don't have to put that like that, but I already did, so too bad. So upper minus lower. 3 times 7 minus 3 times 3. 3 times 7, what's that? 21. 3 times 3, that's 9. Yeah, 21 minus 9 is 12. Yeah. You guys don't look entertained, guys. Let's do another one with geometry first. So that way, when you take your Delta Math today, you're not going to say, Chavez didn't go over any of these geometry columns. Well, now that I'm doing them, then yeah, I did, because we're doing it with geometry. So this is just a linear line. I'm just looking at this part. That dx, remember, is just like delta x. It's like summing rectangles. So I'm just looking at that x there. So that's just a linear line, like that, from 0 all the way to 5. And it goes forever, of course, right? But I like cared about that. And look at this shape. This is just what type of shape? A triangle. Since it's y equals x, that means this y value up here is 5. So according to geometry, let's see. 5 times 5 is 25, and then divide that by 2. That should be 12.5, this area. All this area. So let's see if we're doing the antiderivative. Let's see if we get 12.5, guys. So antiderivative of x is x squared over 2. And I'm evaluating this from 0 to 5. Again, I'm just doing upper minus lower. 5 squared divided by 2 minus 0 squared divided by 2. And again, well, it's not magic. There's a reason for this. 25 divided by 2, wow, that's 12.5. It works. By the way, the rule that we just did is FTOC number 1. Fundamental, the F stands for fundamental. The T stands for theorem. The O stands for of. Maybe it doesn't even deserve to be in the acronym there. The C stands for calculus. Fundamental theorem of calculus part 1. What is that? It just means that if I have f prime of x dx, that's just going to be f of b minus f of a. I should have used a different color. Sorry, guys. Integral a to b, f prime of x dx, f of b minus f of a. If you Google fundamental theorem of calculus part 1, if you Google, because you're like, oh, I want to know more about it, they're not going to use this notation. They're probably going to use a capital letter F that indicates antiderivative and all that good stuff. So don't get confused. Where's the proof? Why does it equal? We're going to talk about that tomorrow, because I don't want to give you guys a headache today. Not that it's a headache. It's a really cool thing to do, like geometrically wise, but still, just in case. All right, guys, let me come back. You guys are already back, so let me come back and I'll put you guys up on the big screen so Godinez can see you guys.